2b. So 2b. Peripi's neighbour also grows pumpkins. He has measured the weights of his pumpkins and has determined that the probability that one weighs more than 4.9 kg is 0.024. Well, the probability that one weighs less than 3.4 kg is 0.067. Assuming a normal distribution, calculate the mean and standard deviation of the weights of the neighbour's pumpkins. So what's the verb there? The thing we're being asked to do? It is to calculate. And we're being asked to calculate what? The mean and the standard deviation. So it's an inverse question. We're working backwards, and that we're given some probabilities and we're being asked to work out the actual mean and standard deviation that's needed. So the first thing you do in a question where the normal distribution is being used is what? You sketch a normal curve. Just a rough sketch is fine. We're going to make ours quite big because we know that we're going to need to be labeling quite a bit of stuff on it. In your actual exam, you'll get more space than this. Like that. Now, we don't know what the mean is. So, question mark. And we don't know what the standard deviation is. We do know that for any normal curve, 99.7% of the data lies within 3 standard deviations of the mean. So 3 on each side means 6. And so we're going to slice and dice our curve into 6 standard deviations. So slicing and dicing. 1, 2, 3. And slice and dice, and same on the other side. And what we're trying to work out along with the mean is we're trying to work out the width of one of those standard deviations, so the width of one of those slices. Okay, so what information are we told in this question? Well, we're told that if we look at 4.9 kg, we're told the probability that one weighs more than that is 0.024. So that's going to be right up near the top, isn't it? So somewhere around here. So we're going to shade that in. So 4.9 kg, and the red area has to be 0.024. So the top 2.4%. And at the other end, we're told that 0.067 weigh less than 3.4 kg. So the bottom 6.7% weighs less than 3.4. So these are certainly not drawn to scale. We actually don't have to have it drawn accurately. It's just that we can get it so we can visualize what's going on. Okay, so what else can we do? Well, what do we have? What formula do we have that links our x values to our standard deviations? Because it's the standard deviation and the mean that we need to find out, isn't it? So if we look at our tables, look at our formula sheet, and here it is. And you can see the formula here that links z to x, to the mean and the standard deviation, and it's z equals x minus the mean over the standard deviation. So this formula is definitely going to be useful because it includes the things we need to know, which is the mean and the standard deviation, and it also includes the thing we do know, which is our x value, and our z values, which we can find out. So we need to find out the z value that corresponds with the bottom 0.067, so the bottom 6.7%, and also the z value that corresponds with the top 2.4%, don't we, for this question? So how are we going to do that? Well, you can use your tables for this to find the z scores, but it's a wee bit tricky. It's actually easier if you use your graphics calculator. So what we're, just to clarify, we're trying to find the z score for the, we'll call it the lower limit of this region, and the z score for the upper limit. So if you use your graphics calculator and you go into menu stat distribution, and instead of going NC, to go inverse normal, so inverse N, and depending on your calculator, mine only gives me the option, I think, no, mine gives me the option of changing the tail from the left to the right to the center. If I want to know 0.067. I want to know the Z score that goes with 0.067. That's my left tail. So I'm going to make sure tail is left. And the area to the left is 0.067. And because I want to work with the Z score, it's the Z score I want to find out. Well, Z is, remember, what is Z? You need to know this. Z is the number of standard deviations away from the mean. So your Z score when you're at the mean is going to be 0, isn't it? Because at the mean you're 0 standard deviations away from the mean. So if we're dealing with Z as our units, that means the mean is going to be what? The mean is going to be 0 by definition. So in the standard deviation, well, trick question. What's Z again? Z is the number of standard deviations away from the mean. So if we're dealing with Z, the standard deviation is 1, isn't it? Okay, because we're counting how many standard deviations. So standard deviation of 1, mean of 0, and area to the left is 0.067, and I want to find out my Z score. So here we go. So execute. And I get negative 1.4985. So I'll write that down. Here we go. So Z lower equals negative 1.4985. Now you got credit if you found that. So this question, if you fully solve it, you get excellence. If you get both the Z scores, so the lower and the upper Z score, you get as far as an R for merit. So let's find the upper one. So how are we going to do that? Pause the video and have a go at finding out the Z score for the top 2.4%. Okay, so how we do it is we stay in inverse again, normal inverse, and instead of tail to the left, we want the tail to the right. So I'm going to change this to right, and the area to the right is 0.024, so I'm going to type in 0.024, and standard deviation is 1 and mean is 0. Why is that again? It's because we're dealing with Z as our unit. So execute, and we get 1.9774. So let's write that down. Okay, so getting this far got you R for relational thinking. So R was towards merits for getting this far. Okay. So now let's just reread the question again. What are we being asked to do? It says, assuming a normal distribution, calculate the mean and the standard deviation. So how are we going to do that? It feels like we don't have enough information yet. So let's write down what we do know. We do know the formula, x minus the mean divided by the standard deviation equals z. So let's have a wee play with that. Okay, so when in doubt, sub in what you do know into that formula. So if we start with the left-hand z score of negative 1.4985, so let's sub that in. So we're going to be using the information on the left and subbing that in. So z is negative 1.4985. What else do we know? We know the x value is 3.4 kg, so we'll sub that in too. We don't know the mean or standard deviation yet. When you're dealing with an equation that has a fraction in it, it usually makes it simpler to cancel the fraction out. So how can we get rid of the divided by standard deviation bit? Well, we can multiply both sides by the standard deviation just to make it a wee bit easier to work with. So let's do that. Like so. Now, that's not enough. We've got two unknowns, so we need a second equation. So a second equation is going to be the same thing using now the right-hand limit or the upper limit. Okay, so let's write that down. And again, start with our formula. So x minus the mean divided by the standard deviation equals z upper. And let's sub in everything we know. So we know the z upper score. So this z score is 1.9774. So let's sub that in. And what else? We know the x value is 4.9 kg. So let's sub that in. And again, we don't know the mean or the standard deviation. Okay, so we've done what we did last time. And again, let's rearrange it so it's not a fraction. So we're going to multiply both sides by the standard deviation, just to make it simpler. Okay, so we've now got two equations. I'm going to call them equation 1. That's equation 1. and equation 2. Now, two unknowns, two equations, so it's a simultaneous equation. So let's put them together, because remember our goal is to find the mean and the standard deviation, and they're the same in both of these equations. Now, because they're in the same form, the easiest way to solve these is the elimination method, which is where we simply add the terms, or we subtract the terms from the two equations. Now, we can see that what's in both of them is mu, and so we can also see that the bigger number, or the positive number in the case of the right hand side, the bigger number is in equation 2. So the easiest way to do this is to take everything in equation 1 and subtract it from equation 2. So I'm going to go equation 2 minus equation 1. So that means I'm going to focus on firstly the numbers on the left. So 4.9 minus 3.4. So 1.5. So now I'm going to focus on the mu symbol. So negative mu minus negative mu, which is just negative mu plus mu, which is going to be 0, isn't it? So that's going to cancel out, and it's just going to be 0. So minus 0 equals, now I'm going to focus on the numbers and the sigma symbol on the right hand side. So 1.9774 sigma minus negative 1.4985 sigma. So I get 3.4759 sigma. Now I don't need to bother writing the minus 0. So now I've got a simple linear equation with one unknown, which means I can solve it. Because I've eliminated one of the unknowns, I've eliminated the mu symbol. So divide both sides by 3.4759, and I get 1.5 divided by 3.4759 equals 0.4315 to four significant figures, which must be my standard deviation. I'm actually not going to round it just yet, because I know I'm going to be using this number again. One way of getting around that, I can round it in my answer, but I can actually also save it on my calculator, so I don't lose any accuracy. To save a number on your calculator when it's not your final answer, what you do is you type the arrow, right arrow, and then you go alpha, and then the button below alpha has a wee A above it. A is like a directory. I'm going to save it to A, then I'm going to hit execute. And now it's saved as A. I'll show you what I mean. So now I've saved it. If I go alpha A again, it recalls it, and I go execute, and it's saved. So I can keep that, but I can round it in my answer. So 0.4315 kg to 4 SF. But now, when now I need to sub that number in to find the mean, don't I? Because the one part of the question was to find the mean. So I can use, what's the easiest equation to use, do you think? Well, I'm going to use equation 2 just because it doesn't have the negative value in it. Always go for the easiest one. So I'm going to substitute in 0.4315, etc., not rounded, into equation 2. So the sigma becomes 0.4315, etc., unrounded. And I need to rearrange that to make the mean the subject. So if I do that, I can say 4.9 minus the right hand side, 1.9774 times standard deviation must equal the mean. So I'll grab your calculator out and we'll work out what it is. So the mean equals 4.9 minus 1.9774, and I'm going to use my saved value of the standard deviation, so alpha A, which means that it won't be rounded, so it's a bit more accurate. Execute, and I get 4.047. So I'll round it to four significant figures. Right, so Now, just check if we've answered the question. Was that all we had to do? Always check there's not the check the finer print. Have we been asked to write about any assumptions or anything like that? Just making sure. No, just calculate's the only verb in that last sentence, so we've done it. And always stop and make sense of your answer. Is it sensible? So 4.047 kg. Does that look a realistic figure? Yeah, it's between the 3.4 and the 4.9. So that's reasonable, isn't it? Standard deviation should be roughly a sixth of the range, 0.4315. Is that sensible? Yeah. And if it's sensible, it usually means it's right. So if you got both of those, that was worth excellent. So that was a T. It's worth practicing some more of these. There are questions like this in the D&D revision book if you've got it. Also in the Sigma textbook. Ask your teacher if you'd like to practice some more like it. Well done.